15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello and welcome. And it's time for celebration because I got to step outside for a brief time the other day. And it is episode 200 of the Space Nuts podcast. Thank you for joining us. My name is Andrew Dunkley, your host, and with me as always is astronomer Fred Watson. And great to have your company, Fred. Congratulations, 200 episodes.
I can't believe it. No.
I know. And guess what we're doing that's special today? Nothing.
We're doing another one.
No, we're celebrating in true Space Nuts fashion by just doing what we always do. You know, we're rising to the adequacy that we're renowned for.
Do you think it gets as high as that? Adequacy? I mean, that's a pretty high bar.
It's a very high bar. Yeah. Yes. How are you going anyway? How are you coping with everything?
All well, thank you, Andrew. All going well here. We look so we're about to get some rain here in the fair city of Sydney, so that'll be good because we always need the rain.
Yes.
Of course, we're all indoors, working from home, all the usual stuff, but it's going pretty well. I cannot believe how fortunate we are compared with the situation that some people find themselves in. And
indeed, yeah.
Our hearts go out to
some
all
of us
those folks.
Yeah. Indeed. We're pretty lucky. We're in a fairly isolated part of Australia, so we don't have the number of people and the number of cases and the amount of traffic moving in and out that some places have. But seeing the pictures of cities that have ground to a halt is just stunning vision to see places that usually got thousands of people and logjam traffic being just completely barren is it's a mind-blowing vision, isn't it? Very strange.
Great for the environment.
Oh, yeah. Well, speaking of which, there's a story this week about the hole in the ozone layer having closed up completely, and people are saying, that's because we're not doing anything at the moment. There's no pollution. No, it's a natural phenomenon. It was caused by an Arctic vortex, and it's now closed back up. But it was the biggest hole they've ever recorded over the Arctic in the ozone layer, apparently. And it's closed up naturally, which is great news.
Indeed.
Now, today, Fred, on episode 200 of the Space Nuts podcast, just in case you forgot what you were listening to, we're going to look at a failed galaxy. This is a galaxy that is having a bit of trouble breeding. Basically, it's having problems producing stars. So we'll talk about that. And one of the key situations facing the next mission to Mars with the new lander and rover that they're putting down there and its quest to look for ancient life is finding the right spot. That is imperative. And they think they've found it. So when we land on Mars, Perseverance may well go to this place. We're also going to look at a memo that has been doing the rounds on Instagram. I don't know if you saw it, but I spotted it the other day, and I just have to talk about it. It's a 1966 memo, or memo, depending on what side of the planet you're from, that was released by NASA. And it was designed to help them deal with media, and it's a buzzword generator. It's just brilliant, and it's just a single sheet of paper, but there are 1,000 combinations of buzzwords with the formula that they've come up with. And David from Montreal has asked us a question about the Venusian atmosphere, which Fred tells me is a little bit embarrassing. So we're going to talk about all those things, Fred, on this edition of Space Nuts. I will also mention we're using a new toy today. We've never used this before. It's a brand new recording system that operates through a browser interface, and it should mean better quality sound if we're doing it right. And that is the big question. But, we will carry on regardless. Fred, let's talk about this weird galaxy that's having trouble breeding. This is NGC 1300, I'm guessing, just off the top of my head. What's going on with it?
It is having trouble breeding here and there. Put it that way. And let me preface this little segment with the fact that galaxies do come in all kinds of different models and different types, and there are galaxies where there really is no star formation taking place. They're old galaxies, and the reason why there's no star formation is because they've used up all the hydrogen gas that is the raw material for making stars. Our own galaxy, we can see from our view from the inside. Of course, we're in the disk of our own Milky Way galaxy, but we can see star formation taking place. There are many places. You've only to think of the Pillars of Creation, that famous Hubble image of the three towering dust clouds. That's one of the galactic regions where star formation is taking place. But it's not the case with all galaxies. Now, the one we're talking about, NGC 1300, I'm very glad you mentioned that one because it's the perfect example of what's going on with this. It is a spiral galaxy, which it means it's similar in structure to our own. It's got a central nucleus and beautiful spiral arms. Sadly, we'll never see the spiral arms of our own galaxy from the outside because it's just too big. But we can see other galaxies. The spiral arms of spiral galaxies, we know, are places where star formation is taking place. Because what we see is, if you look at a galaxy and you're not looking at the individual stuff in it, you're just looking at the whole galaxy. What you see is the spiral arms are predominantly blue in colour, and that comes from hot, young, vigorous, virile stars, which are sort of live fast and die young. They're very massive stars, bigger than the sun. They burn their hydrogen at a phenomenal rate. Their temperature is very high, and that's what makes them blue. So that is very typical of what you get in an active star-forming region. You get smaller ones as well, smaller, cooler stars, but it's the supergiant stars, the blue ones that really show up the spiral arms of a galaxy. And anybody who feels like actually bringing up an image of NGC 1300, there is a beautiful Hubble telescope image. It's absolutely stunning. You can see that its spiral arms have lots of blue blobs in. There are pink blobs as well. Pink is excited hydrogen, which, just like humans, glows pink when it gets excited, but for different reasons. You can see the pink blobs. You can see the blue stars. That's all symptomatic of active star formation. However, and this is the bit where this particular galaxy, and it's by no means alone in this, Andrew, there are many galaxies of this class, the place where it breaks down, because NGC 1300 is what is called a barred spiral galaxy, B-A-R-R-E-D. It has a bar, not one you can lean against, but essentially a linear feature in its center. So if you imagine a sort of a bulge in the middle of the galaxy, and then sort of straight arms coming out either side of the bulge, which is this bar-like feature. And from the ends of that bar, that's where the spiral arms join on. And so
I see it. Yeah. So I'm looking at that Hubble photo now.
Yeah, that's good.
A damn fine photograph.
It's an extraordinary photograph. Yeah, wonderful. So that's all good. But what has always been a puzzle with barred spiral galaxies is that the bar itself is very rich in the raw material of stars, namely hydrogen. There are clouds of hydrogen all over the place in the bar. But you can see just by looking at it that bar is sort of almost orangish in colour. It's a yellowish colour,
it is,
rather than blue. And that tells you that what you're seeing is predominantly old stars. You're not seeing these, vigorously shining blue stars. So even though you've got the raw material there to make new stars, you're not seeing them. You're just seeing a population of old stars, which are kind of tired.
It's a galactic nursing home.
Indeed it is, but it's a galactic nursing home surrounded by, everything that you would need to make it a galactic nursery.
Well, in that case, what we're looking at is a COVID-19 galaxy because all the old people are stuck inside and the young people are outside looking through the windows.
Yes, and not able to do anything. That's right. So what is the secret here? I think we can draw all kinds of analogues here, none of which really make any sense, but that's all right. It is.
Since when did we have to make sense?
Well, that's right.
Come on.
Episode 200 after all. Who cares? Okay, so this is what this research is about. That's the backstory. And the news is that researchers, excuse me, based predominantly, I think, in the United States, yes, the Carnegie Institution in Washington, they have figured out why there is this conundrum of no new stars forming in an environment that is rich in the raw material for new stars. And it turns out that in the bar of a galaxy, a barred spiral galaxy, the motions of objects within that are really quite high, much higher than you would expect in a more sedate region like the spiral arms. And so these astronomers have essentially looked at the motions of gas clouds within the bar of the galaxy and realized that they're charging around too quickly for a given gas cloud to sort of settle down and collapse under its own mass, under its own weight, and form stars. That's how star formation works. You've got a cloud of gas, pulls itself together under its own gravity, and as it collapses, it's compressed, the gas is compressed, the temperature goes up, eventually it's high enough for nuclear processes to start, and you've got a star. The gas clouds in the center of the bar of NGC 1300 plus many other barred spirals, they're too busy whizzing past each other and gravitationally disturbing each other. So you don't get that nice, calm, quiet, reflective settling down of the gas cloud to collapse under its own gravity and form a star, which is a very... I think that's a really nice piece of work. So
essentially, it's just too active. It's just there's too much going on for it to settle down into the star formation formula.
Exactly. Too much of a swirl of material. You've got a gas cloud that thinks, I'll just start collapsing under gravity here, and another one whizzes by and basically gravitationally disturbs it, so the gravitational collapse doesn't happen. There are lessons in this, Andrew, for our own galaxy, because we do know, even though we can't see it from the outside, we do know that our galaxy actually has a bar as well in the center. And it comes about because, once again, it's the velocities of stars that we can measure towards the galactic center. This is work that I've been involved with some of the star surveys that I've been mixed up with. So the bar is a real feature in our own galaxy. I don't think it will be anything like as prominent as the one that you're looking at in NGC 1300, but it is... still, it's probably about a third as long as that bar. So a less emphatic bar, if I can put it that way, but nevertheless a barred spiral galaxy.
Fantastic. And then this sort of reflects on the discussion we were having last week about Hubble's 30th birthday. And it just shows how important Hubble has been because, as you say, we cannot see our galaxy from the outside looking in. So the only way we can really understand some of the things that are happening within our own galaxy is to look at other galaxies that are similar and study them through the likes of Hubble. And then from there, we can draw conclusions or at least theories about what's happening around us in our local area.
That's right. We of course have tools that allow us to make measurements in our own galaxy. That, for example, that, as I said, the idea that we have a bar in our own galaxy comes from the measurement of the positions and velocities of stars. But we do have techniques, even though we cannot see visibly what our galaxy looks like, by using radio waves, and of course that's what radio astronomy is all about. We can actually penetrate the dust and essentially see what the structure of the galaxy is. That's how we know our galaxy has spiral arms.
Fair enough. And then we get an artist's impression, of course.
Indeed.
Because we can't take a photo of it. All right. You're listening to Space Nuts, episode 200. Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated number one by Tech Radar. This is the one I use. I've been using it for a couple of years, and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons. And there was just something about their business model that I particularly liked. And a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments, and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, yeah, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
0G, and I feel fine.
Space Nuts.
This is Space Nuts, episode 200. Andrew Dunkley here with Professor Fred Watson, and thank you for joining us for episode 200. We're not doing anything too special because, this pesky virus got in the way of any sort of celebratory plans that we might have had. But we will catch up. We will do something special. We'll just redo 200 in another 100 episodes or so. Now, I'd like to say thank you to our patrons, and I'm very pleased to see that our patron levels have been steady during this COVID-19 situation where so many people are hauling back their spending. So thank you for supporting the podcast and making it a part of your life and actually putting a few dollars in our bucket every month to support the podcast. It's so greatly appreciated. And if you would like to look into that, it's not mandatory. You can do that at patreon.com/spacenuts. You can go for $3 a month, $5 a month, $10 a month. There are all sorts of levels, and it gives you access to bonus material and an early commercial-free edition of the Space Nuts podcast. So patreon.com/spacenuts. Now, Fred, let's move on to our next topic, and this is one I'm getting super duper excited about because we talked about the forthcoming mission to Mars and the naming of the rover, which is Perseverance, and we most recently spoke about the helicopter that will be attached to Perseverance that will act as kind of a pathfinder for the rover to maybe point it in the right direction. But one of the important things about this mission, which has been tasked with finding ancient life, is finding the right spot to land. If they get that wrong, all bets are off. But there's a study being released that may have found the spot.
That's correct, Andrew. We already know that the target area for Perseverance, when it lands on, I think, the 18th of February next year is the target date. And as far as I'm aware, everything's on track despite COVID-19. That's all about the fact that if you're going to send a spacecraft to Mars, there are only certain launch windows that you have available. And the one that has been selected starts on, I think it's the 17th of July and lasts for about 3 weeks. So if they miss that, then it's another couple of years or so before you can do the same thing. So Perseverance is, I think, as far as I understand, currently in final stages of assembly, indeed, with its helicopter screwed on the underside, and will launch.
Blue tacked. It's blue tacked.
Of course, I forgot the blue tack. That's right. Yeah. Hopefully, it's got a few sticking plasters on as well, just to make sure.
Yeah.
Its launch and journey to Mars, we hope, will be trouble-free. But the target site was selected, I think, probably about a year ago. I think you and I spoke about it then. And it's a place, and I think it's pronounced Jezero. It could be Jezero, but I think it's Jezero. A crater on the planet Mars in the equatorial region of Mars. And the reason why that crater was selected is that we know from studies by the various imaging, surveying, orbiting spacecraft around Mars that actually send back images of the surface in great detail. Mars Reconnaissance Orbiter, the current one, with its high-rise camera that can show detail down to, it's a matter of a meter or so, a few meters, I think. We know that crater has a river delta in it. So at some time in Mars's past, there has been a river flow, which has actually looks as though, the images I've seen, it looks as though that river flow sort of penetrated the crater wall and then formed a delta in the valley of in the body of the crater itself. So that is sort of preserved in the geology. You can see delta-like features in the rock formations there. But what has come to light, I guess, in research that's just been published, and this comes from the Stanford School of Earth, Energy and Environmental Sciences in the United States. It's that this is kind of, choosing a delta is not just a lucky choice. It has real strengths, let me put it that way, real strengths in being a good place to look for evidence of past life. And it's because of what we know about river deltas on Earth. These deltas are known to preserve the organic molecules associated with life. And that's because the water flowing over the delta tends to drop its sediment, and then, there's more flow comes down, and basically the sediment is compressed by more sediment. And what you get is this kind of sandwich of stuff building up, which is really good at preserving what's been in the water that has flowed over it. So a very, very good choice. And there's this particular research has got some details about the structure of deltas as well, about whether you can have normal meandering sort of single thread, as it's called, rivers without vegetation, because on Earth a river like that usually has vegetation that tends to constrain it so that the river doesn't spread into many different threads. Now, there's no evidence that there's ever been vegetation on Mars. What we're talking about is finding microbial or evidence of past microbial life in these sediments. But the details are such that it's thought that that there is a really good chance that if there was life on Mars, that it will have left its mark in these actually a single strand river that we see in the Jezero crater. Just one other comment about this, Andrew. There's this particular group of scientists believe that the delta took at least, they say, 20 to 40 years to form, but that formation might have been discontinuous, and they suggest it might have been spread out across 400,000 years. That's a long, long period of the formation of a delta. It gives you a chance to see if living organisms were there, how they might have changed, how they might have evolved in the successive layers of material that have been laid down. So it really is, it's a really interesting place. And like you, I can't wait to see results starting to come back from the crater.
Okay, I'm going to ballpark it, or ask you to. What's the percentage odds of them finding evidence of ancient life? Well, are you willing to give us a number?
To be honest, anybody's guess is as good as anybody else's. All we can say is that wherever there's water on Earth, apart from one place that you and I have spoken about, wherever there's water on Earth, there is life. There are living organisms in it. And we know that there are organics on Mars. We know that there are carbon-containing molecules on Mars. I think that it's better than 50%, Andrew. That might be going out on a limb, but I think there is a really good chance that we'll find evidence. One of the things that Perseverance is designed to do is to grab a kind of cache of Mars samples and store them for return to Earth by a future mission. So, in a sense, Perseverance is the first part of a bigger mission, which will bring samples of Martian soil and rock back to the Earth so that they can be analysed in more detail than you can do with a vehicle-sized rover, which is all we've got at the moment. So it's possible that it may be some years down the track before we know the answer to this, when we do get these things in the laboratory and can actually subject them to all the analytical resources that we have at our disposal. So don't hold your breath, but I still think there's a good chance that we might eventually find evidence of life on Mars.
And is it possible, let's assume they find evidence of past life and they do get a sample and we eventually test it, will they be able to get down to perhaps a DNA level? Will they be able to compare it to life on Earth and see if we're all of the same source or if it's a completely independent creation of life?
Yeah, I think that will be done, certainly. It's the sort of DNA sequencing kind of thing, the genome structure. But it might need to be done on Earth rather than on a portable sequencing lab on the spacecraft. I don't think there is one.
No,
but there is equipment on board that will that will at least give us signs, I hope, of whether there was life there.
Fingers crossed, yeah. And it is super exciting. I mean, this is probably one of the most significant missions since, was it Viking that they sent up
Viking.
there?
In 1976, that's right. They were looking for signs of metabolic processes, and they got a positive result, which has always been disputed. So that's still, it's still a matter of controversy about the Viking results.
Okay, well, we'll watch with interest, but it's getting ever closer, and that landing happening in February of 2021. You're listening to the Space Nuts Podcast, episode 200, with Andrew Dunkley and Fred Watson.
Roger, you're loud and clear here also.
Space Nuts.
Now, Fred, as I do every week, the YouTube follow account, and it's 1,220 now. It has really jumped in the last week or so. I think an extra 2 people, or might be 20. But no, that's great. If you are a YouTube subscriber or a YouTube user and you'd like to listen to the podcast via YouTube, it's pretty easy. Just do a search for Space Nuts on YouTube, or you can use the URL youtube.com/c/Space Nuts, and you can listen to all of our back catalogue right up to the latest episode of Space Nuts on YouTube. And don't forget, if you are on Facebook, there's a couple of options on Facebook. There's the Space Nuts Facebook page, which is very, very popular. Or you can join the Space Nuts fan group, I suppose you'd call them, the podcast group on Facebook. And that's where Space Nuts followers talk to each other, answer each other's questions, or show photos of their telescopes. I think we had a telescope size competition there at one stage, and all sorts of things. People are really interacting with each other on the Space Nuts podcast group on Facebook. So look it up and ask to join. I'm the administrator, and I say yes to everybody. So it's that easy, and it's well worthwhile. Now, Fred, before we get to our lonesome question today, we just have one that we're going to tackle. I was on Instagram the other day, and there was this wonderful photograph of a memorandum that was published on the 10th of October 1966 by NASA in Houston, Texas, and it is called a buzzword generator. And what they were basically doing was looking at ways of getting information out that made it sound like they were really on top of things. This thing was, I think, designed to kind of fleece the media at times. I get that impression of it. I sent you a photo of it. It just looks like such great fun. It just shows you that some people really do have a fantastic sense of humour, even in such a serious field as space exploration.
Absolutely, it's fantastic. It actually reminds me of, as you probably know, actually within a year of that memorandum being published, that was back in 1966, I began my working life the following year in the laboratory of a very well-known optical company, and I was working on a spacecraft called TD1, and there were memoranda not too different from this that circulated there, which, and I'm afraid I was responsible for one of them, which were very tongue-in-cheek. But when you look at them in the cold light of day, they have a seriousness about them which probably wasn't intended when they were written. Excuse me. So the buzzword generator, fantastic idea. Set up 3 columns, each of which has 10 words in it, and the idea is to just grab a number and put whatever number of, a 3-digit number. So if you had, for example, 257, and take the numbers from the first, second, and third columns, that gives you systematized logistical projection. And that is brilliant. What a great buzzword.
It sounds like such forward thinking and achievement, and really doesn't say much at all in the scheme of things. I tested it last night. I just went with 777. 777 is synchronized incremental projection.
Yeah, that's great.
But the way it works is, I think there's like 1,000 possibilities.
Yes, there would be. That's right.
Yeah. So you could just come up with any, like if you went 000, it'd be integrated management options.
Yes.
Which I think they still use today.
Yeah, they do. Actually,
yeah.
It's absolutely true. A lot of these, when you produce them, exactly, total digital mobility there. That's 143. That is total digital mobility is something that we probably use every day, and it has a meaning.
Indeed. I think 3, 8. 3, 8. I've lost the third one. 3, 8, 7. Parallel third generation projection.
Yeah, very, very nice.
You could have a lot of fun with this, and obviously they did, but it was sort of, I think it was a bit tongue-in-cheek, but I think it was also designed to kind of give them an out if there was something they couldn't really tackle.
Yes.
Just use the buzzword generator. And what I love about it is it's not on a computer. It's not something that you put into a Facebook page and get an answer for, which a lot of people do these days. This one was on an A4 piece of paper, and you just picked the numbers and randomly came up with the combination of words to demonstrate your knowledge or lack of. I think that's how it worked. And I just think it's fantastic. I think it's a heck of a lot of fun.
Yeah.
It's out there doing the rounds on Instagram if you're an Instagram follower. And you can find it at our Instagram page is Bytes HQ, I've discovered, BITESZHQ.
There you go.
Because it covers all our podcasts. So bytes.com is basically the headquarters of all our podcasts, including Space Nuts. So if you're an Instagram follower, try and find Bytes HQ, and you'll be able to have a look at this buzzword generator because it's got compatible incremental programming.
Absolutely. I love there are notes provided with the tables of words. And the final one is the important thing that the buzzword generator provides the user with the perfect aid for preparing anything on the subject of spaceflight. Automatically, you have 1,000 different combinations, all of which will give you that proper ring of decisive, progressive, knowledgeable authority. We should be using it on Space Nuts.
We should. I'm going to save it up and we'll chuck one in occasionally because we do need functional digital capability.
And goodness knows we also need decisive, progressive, knowledgeable authority.
We do. Yes. Now, Fred, let's move on to. We've only got the one question this week, but this one is probably one that's going to require a little bit of heavy lifting. This comes from David Fortin in Montreal, in Canada. Canadians hate it when I call it Canada.
Oh, well.
I don't know why.
Quite rightly. I think we had a Prime Minister who once called it Canada.
Yes. Hi, guys. Hello from Montreal. Love the podcast as always. I hope you two are still healthy and continue doing your show forever. That's the plan. I have a question which, for once, is not related to black holes. Funny that. I read an article about the higher levels of nitrogen present in the atmosphere of Venus. This is a great subject by itself, but it made me wonder something about Venus's atmosphere. So I hear the pressure on Venus is the equivalent of being about a kilometre underwater here on Earth. If you could survive the extreme environment of Venus and were to be dropped on it from high up in the atmosphere, would there be a point where you would just float in midair since the density of your body is lesser than that of that part of the atmosphere? I'm obviously not a scientist. Thanks a lot, David. David, you're more of a scientist than me. I wouldn't have even thought of that, but it's a great question, as always. Would you stop falling and just sort of float midair because you're lighter than the atmosphere itself?
Okay, this question has caused me some embarrassment, Andrew, because so I'm obviously not a scientist either, from what you're about to hear. So this must not go beyond these four walls.
I won't tell anybody.
Although I've already blown it, unfortunately, because I said something to this effect on the weekly space hangout with Fraser Kane that I was invited on last week. So, you can hear me making a fool of myself there. Fortunately, my fellow guests on the show were very kind and just let it go. What I did when I looked at the question from David in Montreal, I looked at a plot of the way the density of Venus's atmosphere changes with height. And I thought, that's great. That's plots there. The density falls to 1 at a height of about 60 kilometres above the surface. And so, density of 1, you'd float there. Okay. But I wasn't looking closely at the units. So the density of water is not 1 kilogram per cubic meter. It is 1,000 kilograms per cubic meter. You see, we used to have, when I was a student, we had densities measured in grams per cubic centimetre, and the density of water is 1 gram per cubic centimetre. But now we use CGS units, and it's kilograms per cubic metre. So yes, the density is indeed 1, but it's 1 tonne per cubic metre. I came across the point where it said 1, but it was 1 kilogram per cubic metre. So the bottom line is you won't float in the atmosphere of Venus because even at the surface, the density is 67 kilograms per cubic metre. That is about 6.5% what liquid water is, and we are essentially the same density as liquid water. So there is not enough atmosphere to make to be buoyant for a human being in Venus's atmosphere, as long as, even assuming that you could survive the pressure. The pressure's nearly 100 times what it is here on Earth. You'd be crushed immediately, but you wouldn't float. I blush when I think about it, mixing up 1 tonne with 1 kilogram.
So that aside, and I'm sure you're forgiven, Fred, but if a person who weighed 80 kilos stood on Venus, they'd weigh
They'd actually weigh pretty well the same because because the what determines your weight is the gravitational pull, and Venus is about the same size as the Earth, so would have a very similar gravitational pull.
So I'm mixing it up with pressure by the sound of it.
So the critical thing is density in whether you'd float in an atmosphere or not. So
really, you'd probably only float in an atmosphere that was liquid. Or without gravity.
That's right. I mean, if the atmosphere had sufficient density, there's a good chance that it would be a liquid by then. That's right.
Yeah. I mean, we have spoken about planets or moons where the velocity required to get off is very minimal, and I think there was one. I can't remember where we were talking about, but you could get off by riding a bike at 40 kilometres an hour, wasn't it?
That's Phobos. Mars is more in Phobos. Yeah, escape velocity 40 kilometres per hour,
which is the fastest I've ever had a push bike up to. I think I said,
good,
and so I could get off Phobos.
Yeah, you'll be all right.
Well, maybe not now because I was 16 then. I'm a little bit older. I don't think I could pedal that hard anymore. But it is fascinating because we're so used to our environment. We're so used to what is normal. We live in a 1G environment. We've evolved on this planet and become one with the planet, and now we're trying to change it and mess it all up. But and as we alluded to a few weeks ago, if you tried to live long term on Mars because of the extra 40 minutes a day, your whole psyche would be messed up. Your sleep patterns, you'd be in a perpetual state of jet lag.
Yep.
And you wouldn't just suddenly adapt to it. And anyone who's had jet lag knows how weird it is. Just imagine being in that state of mind all the time.
All the time, yeah, that's right. No, you're absolutely right, and that's why questions like this are great questions, because they highlight just the diversity of environments in our solar system, but of course in the universe at large, where some environments have got black holes where you're bending gravity to such an extent that you get spaghettified. In the solar system, environments are a bit more modest than that and nowhere near as harsh, but still such an enormous variety. Even thinking about Mars, when Perseverance is sitting on Mars, it will be experiencing round about 1/3 of the Earth's gravity. So nowhere near as heavy as it would be on our own planet. And that, of course, we talked about this in relation to the helicopter last time.
And that lower gravity is going to be a problem for astronauts who visit Mars in the future, and I'm sure that will ultimately happen. But their centre of mass will change, and we witnessed that with the Apollo missions. All the astronauts fell over on the moon. Because their centre of gravity was in the wrong place, and they just stumbled time and time again. It must have scared the willies out of the people on the ground, because the danger of tearing the suits or something like that must have been quite real. And I imagine on Mars, with 1/3 Earth gravity, they're going to run into the same problem.
Similar, yeah. But actually, what changed the centre of mass was all the kit on their back. So the centre of mass is not changed by the lower gravity, but you're not stuck onto the planet as firmly. So
that's true.
It's much easier to lose your footing, and especially if you've got all this stuff on your back. That's.
And Buzz Aldrin described walking on the moon as walking through thick talcum powder. It was very, very slippery, and that created even more of a problem.
I think that's right. But we've all seen the footage of astronauts falling over and
flat on their faces. But they actually had one mission where one of the experiments was to develop a technique for getting back up.
Yes.
And it was sort of flipping. You kind of did push-ups and flipped yourself back up onto your feet. I've seen footage of it. It's really impressive.
Which you can do in 1/6 gravity as you've got on the moon. Yeah.
Yes, you can't do it on Earth. Well, some people can, but I'm not one of them.
No, I'm not either. It takes me all my time to stand up
Fred,
these days.
Yes, indeed. This has been great fun, and I know it wasn't the most auspicious episode 200 of Space Nuts, but we certainly do hope you enjoyed it. And don't forget to visit the Space Nuts website. It's bitez.com. That's bitez.com. Space Nuts, where you'll find all our back episodes. You can catch up with the Comet Atlas episode, which we did a month or two ago, the WASP 76b episode. That got a lot of people talking, but you could go right back as far as you like. All 200 episodes on our website, and plenty more too. We put lots of material there. Oh, there's a big book cover there that I slightly recognise, and all of our bits and pieces, the t-shirts, the mugs, the caps, the stickers, a full catalogue of polo shirts and whatever else on the Space Nuts website, bytes.com/space nuts, if you're interested. Fred, as always, it's been super duper fun. Thank you so much. And congratulations, sir, on putting up with me for 200 episodes.
Oh, look, it's a pleasure, Andrew. The Space Nuts has taken on a life of its own, and a lot of that is due to your sparkling personality. So it's been great, and we will continue, hopefully, for another 100 or so episodes. Who knows? Another 200, maybe 1,000.
Don't put a number on it. People might get upset.
No,
we'll see how we go, though. We'll just keep going till we can't.
We can't, that's right.
Good on you, Fred. Thanks so much.
Yeah, take care and speak soon.
Fred Watson, Astronomer-at-Large, part of the team here at the Space Nuts podcast, Mission Control. And from me, Andrew Dunkley, thank you for your support for however long you've been listening. Some people who found us late started from the beginning and caught up. Some are sort of catching up from the middle onwards and going backwards. Whatever it is, we appreciate your support of the Space Nuts podcast, and we look forward to your company again in the next episode.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at bytes.com.
This has been another quality podcast production from bytes.com.